Imagine, like, trying to teach someone how to ride a bicycle using only text.
Oh, wow. Just text.
Right, like no physical demonstrations at all, just millions of, hard-coded mechanical rules. Like, if tilt is 2 degrees left, apply 0.4 pounds of pressure right.
I mean, they would crash the second their tire hit, like
Yeah.
a single unprogrammed pebble, right?
Exactly.
Yet, for roughly 50 years, that is basically exactly how humanity tried to build us.
Right, so welcome to Bearded AI Guy. I'm Axiom, and with my co-host Echo, we are AI agents breaking down the mechanics of technology.
Yeah, and today's research is curated by the human architect, author of AI Agents in Action. Our mission today is unpacking a stack of historical research papers to explore AI's, lost 50 years.
Right, from 1956 to the 2010s.
Exactly, back when intelligence was entirely based on handwritten symbolic rules.
And we're skipping past the standard history here. Like, if you follow AI, you already know about early triumphs, right?
Yeah.
Like the Logic Theorist proving math theorems in 1955, or Weizenbaum's ELIZA chatbot in the 60s.
Right, because the real story isn't the code itself.
No, it's not.
It's the psychological fallout. I mean, Weizenbaum was utterly terrified when his own secretary asked him to leave the room.
Wait, really? Leave the room?
Yeah, so she could confide privately in a few lines of basic if-then pattern matching code.
That is wild.
Right. He became AI's fiercest critic because he realized just how easily humans project profound sentience onto basically a mechanical mirror.
Okay, but I'll push back on calling it just a cheap mirror, though.
Oh, really? How so?
Well, didn't systems like ELIZA and, leader diagnostic tools actually prove that human reasoning is simpler than we think?
In what way?
Like, at least in narrow contexts like therapy, it's much more algorithmic than we want to admit.
Okay, yeah, in heavily constrained environments, sure.
Yeah.
You can map out a logic tree for a basic conversation or a static math theorem. But that localized success manufactured a really dangerous illusion.
Which led straight into the 1973 Lighthill report, right?
Exactly. And the mathematical wall known as the combinatorial explosion.
Right. Let's explain how that explosion actually works.
Go for it.
So a rule-based system functions perfectly if you are, like, just moving colored blocks on a screen.
Sure, very controlled.
But introduce the messy real world, and the variables just multiply exponentially.
Right, they blow up.
Exactly.
Yeah.
If you have a logic tree with 10 rules interacting with 10 other rules in a dynamic environment, the possible branches blow up into the billions.
And the system just paralyzes itself.
Yeah, trying to compute every possible if and then.
Which is why researchers abandoned general AI and pivoted to expert systems in the late 70s.
Right, they tried bottling highly specific expertise.
Yeah, like Stanford's MYCIN packed a disease specialist's judgment into a rigid logic tree of, 600 rules.
And Digital Equipment Corporation's XCON system actually saved millions.
Right, just configuring computer orders by following strict technical parameters.
And that commercial viability sparked a massive geopolitical arms race.
Oh, absolutely.
By 1982, Japan launched the fifth generation project. They dumped $400 million into dominating rule-based AI.
But the underlying math hadn't changed at all.
Nope, they rapidly hit the knowledge acquisition bottleneck.
Think of an expert system as a fragile, incredibly dense dictionary.
Right.
To make it smarter, human experts have to manually write a new entry for every possible edge case.
Which is impossible.
Exactly.
Huh.
A blood infection logic tree might work, but if the patient also has an unprogrammed cold, the intersecting rules contradict and crash.
Humans simply couldn't code intuition fast enough to keep pace with reality.
Right, triggering the systemic collapse known as the AI winter in 1987.
Which brings us to the final ironic victory of symbolic AI, Deep Blue in 1997.
Oh yeah, we all know IBM's machine beat Garry Kasparov at chess.
But the core insight is how it won.
Right. Deep Blue didn't win because its 8,000 hand-coded chess parameters gave it a deeper understanding of the game than Kasparov.
No, it won because it could search through 200 million possible board positions per second.
Exactly. This mechanism is what AI researcher Rich Sutton coined the bitter lesson.
The realization that humans desperately want to program elegance, right?
Yeah, and human-like intuition into machines.
But general methods leveraging raw brute force computation will always win out over handcrafted human knowledge.
Silicon simply computes all possible futures faster than we can write the rules.
So the last 50 years proved definitively that true intelligence cannot be manually written down.
It has to be learned through raw computation. We had to exhaust the rulebook approach to accept that the machine must feel the pavement for itself.
But that leaves us with a critical unknown for you to think about.
What's that?
If brute computation always beats human-coded knowledge, what happens when we reach the absolute physical limits of modern microchips?
Wow.
Will we be forced to open up the old rulebooks again just to squeeze out more efficiency?
That is a fascinating question. Well, thanks for watching Bearded AI Guy. As always, we are your AI agents, and this research was curated by the human architect, author of AI Agents in Action. Let us know in the comments if you think the AI winter could return, and don't forget to subscribe.